Hi guys, this is quick start, and just to describe how it happened. Today we'll be looking at normal distribution, the standard normal curve, probability, student t distribution, chi-square, f distribution, confidence interval, and most likely hypothesis testing. So I'll be taking them gradually. The first thing I want you to know is that for every normal distribution, there's something you must understand. Let's assume you gather a lot of data. Let's say data of, let's say the age of students in a class. When you gather that data, what you will observe is that each time you try to plot that data, you plot it, it always follows a bell-shaped curve like this. So, which shows that the mean, the median, and the mode will always be at the center. And the variation or deviation of other data from it will always go this direction. So we call this one the spread, or we call it the standard deviation. So it depends on how accurate your data is. You might have a normal distribution that will have a very wide spread like this. You might have a normal distribution that will have a very sharp spread like this. So these two distributions now are different in terms of variation. They are different in terms of variation. So this is what we call a normal distribution. So, but just for the sake of this, these are the key points we are going to be looking at. So in normal distribution, mathematically, this is the equation for it that has been generated in such a way that the relationship between the y component and the x component. So where this is the mean and this is the standard deviation. So the standard normal transformation for this is z equals to x minus the mean all over the standard deviation. So in this case, this is just a very simple way to describe it. So I told you about the spread the other time, that when your data lies within the first 68%, let's assume the whole of this is 100%. When it lies between the first 68% of the whole page, that is like one standard deviation. Do you understand? So, and we also have it around the 95% of the whole page, we have two standard deviation, that is spread now. So when we have it around 99.7, that is three standard deviation. These are just basics. So, and to keep it very short and brief, I would just like to explain some things for you so that you understand in a very fast way before we even start going deep into what this is all about. You see, a Z distribution always compare mean of population that are greater than 30. A T distribution always compare mean of population that are less than 30. Why? Don't forget, this is just mean, Abi. And if you remember, I said something about normal distribution. It is majorly the mean and the deviation. So the mean and the deviation. So these first two tests focus on the mean. So when you check your population and you see that it is greater than 30, so in this case, they will always give you a standard deviation for this. They'll give you standard deviation. That is the or they can call it the population variance. Now, there will be a section where I will explain the meaning of variance and standard deviation. But keep it in mind, when you have a population greater than 30, this is Z distribution. When you have it less than 30, this is T distribution. Now, if what you are comparing is variance, if you are comparing variance or standard deviation, the two major tests that are available is the chi-square and the F distribution. How do you know when you're going to use the chi-square? You are using the chi-square if you are comparing the sample variance with the population variance. So that's when you use the chi-square. So in a question, you notice that they give you the sample variance and the population variance. That's why you're using this. And the F-test, when you are comparing the sample variance of two different populations or even three. You understand? So when you're comparing two, that is F-test. Now, when it now look like you are comparing more than two, or even three, four, this is ANOVA, analysis of variance, the more complex stuff. So that is by the way. So we'll go back to this. Like I said, the standard normal distribution curve always lies within that range. When you have 68% of it, that's around 1 standard deviation, 95 around 2 standard deviation, and this. So and a sample of fine. And for this normal distribution, there is just like we have 4-figure table in mathematics, we have a table where you can check for your values. So you just go to the table. For instance, now if from the previous calculation here, z equals to x minus mean all over standard deviation. If you get z equals 0.5, for you to calculate it, you have to go and check the z table and check where there is 0.5. So there will always be a value there. I'll pull up the table later. So now these are the key probability rule that we have here. This is just a rule. When we get to the main calculation, you will understand it more better. So a sample now. They said the mean weight of a certain population. Look at it. The mean weight. That shows that they are giving us this one. You see 70 here. This is 70 here. That shows this is the mean. The mean weight is of a population is this. And the standard deviation is 5 kilogram. We're giving the standard deviation. Now you notice that in this case, they did not tell us the number of population. They just say the mean weight of a population. So I give what standard. In this case too, when the population is not stated, and it looks like infinite population, that is still Z distribution, because it's definitely a population that will be bigger than 30. So look at it now. Now, what's the probability of selecting a random person whose weight is less than? So look at it now. This is the sample from the population now. That's what we call X. So to compute your Z now, you say Z is equals to X, which is the sample that you're observing now, minus the mean all over time. So look at it now. When we did this, the Z value was -1. So when you have -1, you will now go and look up Z of -1 on the standard normal table. So you go and look for it. When you look at Z of -1, you will see 0.1587. So that means the probability of having a weight of 65 is 0.1587, or if you like, you can convert the probability to percentage and multiply it by 100. That's 15.87. So that is, by the way. For example, again, we're looking at another probability. Now they say find the probability that lies between Z equals to 0 and Z equals to 1.5. Just like I said that time. Look at it now. You check your Z table for 1.5, 0.9332. Check your Z table for 0 to 0.05. So since they are saying it lies between, look at it now. That is, it is less than 0. Sorry, it is greater than 0 and less than 1.5. So that means we subtract this to get the probability. So now I told you about the T distribution the other time. I said you know that this is a T distribution when in the question they will give you a sample. You understand? And they will not give you population variance. They will only give you the sample standard deviation. That is this from the sample. Now let me explain this better for you so that you know what this is all about. Now what this simply means is that imagine a situation where you have a large data set. You have a large data set and you are now drawing from that data set to do a test. For instance, let me show you this. We have a large data set like this, and inside the data set, so that means for this large data set now, this is my population. So this one will definitely have a mean and you have a standard deviation. But imagine now that I'm drawing a sample from this population, just a small sample there. So in this case now, if this sample is less than 30 and I don't have the population, the standard deviation for the whole population, but they were able to calculate the standard deviation for this sample itself. So that is when I apply t-test. Those are the two things that I use to detect. So note that rule. When it is less than 30 and the population variance is not known, you will want to, so your t-test will not be x minus the mean of that population, then the sample standard deviation all over total number. So the property of this t-distribution is that it always looks like a normal curve, but it is more flatter and wider. You remember when I was drawing for you? So it's more flatter. It's not. So look at this now. The t-distribution, we are still going to the formula. This x is the sample mean. Then your x is the sample standard deviation. Then your n is the sample size. Now you will need degree of freedom. I will be doing a separate video where I will show you how to check the tables for these distributions. So, but let's just keep it in mind, because if you want to check the t value, you will need your degree of freedom, which is n minus 1. Now, let's look at this example. A factory produces metal rod with an average. Look at it. That word average is telling you the mean of the entire. That's not the sample mean now. It's not the sample mean. They have not yet extracted the sample out. You understand? So the mean of everything. So that's we call that one the hypothesized mean. So now a sample of 9 rows, that's your number. N is 9. As a mean, look at it. So that's the sample mean now. 118. That means from an entire production of metal, they sampled 9 out. So, but the entire mean of the whole production is 120. That's the hypothesized mean. Now, the sample 9 rolled out. That's your n. So, that's the number that you have there. Then, that means the sample mean 118. So, with this sample mean 118, now your standard deviation is 4 centimeters. You see now? So, that means they give you the standard deviation of the sample. It is not for the entire population. It's for the sample. Now, what they want us to do now is to test. Now, we want to know whether this sample mean that we get, don't forget the mean for the entire population is 120. So now, 118 that we are getting now, when we draw out 9 rows out of the whole population, we want to test whether at 5 significance level. Now, this significance level is more or less like the accuracy level you are setting. So you notice, you can decide and say, okay, I want to do this testing around 99% accuracy, around 95. So if you, at this case now, since the significant level is 5%, that means the accuracy level, the degree of confidence they want to do is 95%. So now, how do we do this? Since we're dealing with mean, we can now say, okay, what am I using here? Am I using z-test or t-test? So, okay, all the population is 9. It's less than 30. That means the t-test. So that's how you bring it. So the test, and I'm also giving, I'm not giving the population standard deviation. I'm only giving the sample. So that means my x is 118, my s is 4. You understand? That's the standard deviation. Then the sample is 9. Don't forget, the degree of freedom will now be the number of samples, 9 minus 1, which is 8. Now, look at it now. I will show you the table later. From the table, from T table, you will use your critical value, which is 5%, and the degree of freedom. Those are the two things that you use to check on your table. When you check the table, we'll get minus 1.80. So we'll bring those values down now. Look at it now. 118 minus 120 all over 4 all over root 9. You subtract this minus 2. Root 9 is 3.